Welcome to this deep dive. We got a really interesting paper you all sent in about large language models. It's called Evolving Deeper LLM Thinking from Google DeepMind, just published.
Yeah, it's about pushing LLMs to really think deeper instead of just generating text, having them actually solve complex
It's
problems.
like teaching an LLM to plan things out strategically.
It's focusing on those problems that require a sequence of decisions like planning a trip or even scheduling a bunch of meetings. Those are what are called constraint satisfaction problems.
That makes sense.
Yeah.
I think the paper even mentions how some of the more advanced LLMs like Gemini 1.5, they still struggle with some of these benchmark tasks like the TravelPlanner and Natural Plan, especially without some additional tools to help.
Well, yeah, because those benchmarks present those constraint satisfaction problems, but they're in natural language, and accurately translating those into that formal logic that a computer can understand, that's a challenge in itself.
So to help with this deeper thinking, the DeepMind team developed this mind evolution approach, and it combines what they're calling divergent thinking, so explaining a lot of ideas, with convergent thinking, which is like picking the best ones.
It basically starts by generating all sorts of potential solutions, and then it uses something called a fitness function to evaluate them against different criteria.
Oh, so that fitness function scores each solution based on how well it meets the goals and the constraints.
Yeah, like in travel planning, it might check how well the trip plan fits the budget, includes all the activities they want to do things like that.
So how does mind evolution improve these initial solutions that it comes up with?
They have this mechanism called refinement through critical conversation,
Hmm.
and it's essentially where the LLM simulates a conversation between a critic and an author.
Yeah.
So the critic looks at the solutions, finds flaws, and the author uses that to revise it.
Whoa, so it's like the LLM is having a debate with itself to kind of refine its thinking.
And then they also do this thing called the island model to get even more diverse ideas where they have several populations of these solutions evolving independently, and then every so often they'll exchange the best performers.
So it's like having multiple teams working on the same problem, and they kind of share their best ideas.
Exactly.
So does this whole process actually lead to better solutions?
What the paper shows is that mind evolution does really well consistently outperforming all the other strategies that they tested, including just generating a ton of solutions and picking the best one. So that combination of exploring and refining is definitely key here.
That's really interesting. It kind of shows that if you guide these LLMs with the right strategies, you can really get them to do some really complex problem solving. They even introduced this new task in the paper called Steg Poet, where the goal is to hide a message inside of a piece of creative text, like a poem.
Yeah, StigPoet requires the LLM to be creative and also have this kind of hidden logic to encode the message using a substitution cipher.
So how well did Mind Evolution do on Steg Poet?
It did pretty well. With the Gemini 1.5 Pro model, it achieved an 87% success rate.
Wow, okay, so what about on the Travel Planner benchmark? How to do on that?
Well, on Travel Planner, using the Gemini 1.5 Flash model, they got a 95.6% success rate. And then for the problems that Flash couldn't solve, they used the Gemini 1.5 Pro model and got that to almost 100%. And this was all without using a separate formal solver. It worked directly with that natural language, which is pretty cool.
Yeah, that makes it so much more adaptable to like those real world problems where it's hard to formalize things. But this whole evolutionary process sounds like it could be pretty computationally expensive.
The paper does look at the computational costs, like how many calls to the LLMs are made, how many tokens are processed, and the API costs based on that LLM pricing.
Okay, so how does mind evolution stack up in terms of efficiency?
Well, it definitely uses more resources than simpler methods, but it's much more efficient than something like Sequential Revision Plus, which uses a lot of refinement rounds.
And they also look at how the performance scales with the number of generations, right?
Yeah, they found that giving mind evolution more generations led to better solutions, so that iterative process is really beneficial.
So allowing it to learn and improve over time really helps.
Yeah.
Okay, so to figure out how everything works, they also did some ablation studies where they took away or changed some components to see how it affected the performance, right?
Yeah, two components stood out as really important. The critic step in the refinement through critical conversation, and that textual feedback from the evaluation function.
So these both self-critique and external feedback to do well.
Exactly. When they disabled the critic step, the performance tanked, showing how important that internal dialogue is. And taking away the textual feedback also had a negative impact because it needs that specific guidance.
So it's kind of like a student who needs feedback from a teacher.
Yeah, and they also experimented with those hyperparameters, like how many islands to use and the number of candidate solutions.
Trying to find that sweet spot, huh?
Yeah, and when they compared the island model to a single population, the island model did much better, especially on those tougher 10-city itineraries.
Really?
Uh-huh. And they also found that increasing the generations while keeping the total number of candidate solutions about the same also improved the results. So allowing for that deeper exploration through more generations helps.
So more generations, more exploration, better results.
Yeah.
Okay, let's move on to that natural plan benchmark, specifically that trip planning task, which presents a kind of different challenge, right?
Yeah, definitely.
This trip planning task, it's all about finding like the best sequence of cities to visit, taking into account all those flight connections and scheduling constraints.
It's kind of like those travel websites that help you find the cheapest multi-city flights, except the LLM is acting as the travel agent.
And did mind evolution beat those other strategies on this task as well?
Oh, yeah, it got a 96.2% success rate on the validation set and 94.1% on the test set using the Gemini 1.5 Flash model.
And I'm guessing using that Gemini 1.5 Pro model for those leftover problems got those numbers close to 100% again.
Yeah, pretty much. But it's interesting because that best-of-N strategy, the one where you just generate a bunch of solutions and pick the best one, well, it actually did better on this trip planning task compared to the travel planner.
So that means the type of problem and the constraints really affect how well these different search strategies work.
And it shows how mind evolution can adapt to all sorts of different planning problems.
So the more complicated the planning problem, the more useful mind evolution becomes.
We also saw that the trip planning task got harder as we added more cities to the itinerary.
Okay, so what about the meeting planning task, the one that focuses on scheduling meetings between people?
Meeting planning adds another layer of complexity because there's an optimization goal. It's not just about finding a solution that works, it's about finding the best solution to maximize the number of meetings scheduled.
So the fitness function has to not only check if a schedule meets the constraints, but also how well it optimizes for the outcome.
On meeting planning, Mind Evolution achieved an 85% success rate on the validation set and 83.8% on the test set using that Gemini 1.5 Flash model.
And I bet adding the Gemini 1.5 Pro model for those trickier problems pushed those success rates way up.
Over 98%, actually. But the paper doesn't just report these success rates and computational costs. They also go deeper analyzing how different parts of mind evolution contributed to its performance through those ablation studies.
So they're kind of like peeking under the hood to see what makes it tick.
One of the big findings was how important that refinement through critical conversation process is.
The one where the LLM analyzes its own solutions and looks for flaws.
When they took out that critic step, the performance dropped a lot, which means just generating ideas isn't enough. It needs to be able to look at those ideas critically and find ways to make them better.
It's like it needs to be its own editor.
Yeah, and they also found that getting rid of that textual feedback from the evaluation function also hurt performance. So it needs that clear, specific guidance to understand how well its solutions are actually meeting those problem requirements.
So both internal self-reflection and external guidance are key for these LLMs to do well on these complex tasks.
They also looked at how different hyperparameter settings affected mind evolution's performance, like the benefit of using that island model.
So how did the island model compare to just using a single population?
Well, the island model, with its multiple populations and all that sharing of ideas, consistently did better, especially on those harder trip planning problems.
No. So having those different groups working and sharing their best solutions really helped. And did they find that increasing the number of generations helped the process?
Increasing the number of generations generally led to better results, even when they kept the total number of candidate solutions roughly the same. So giving mind evolution more time to explore, refine, and evolve its solutions really pays off.
More time, more learning, better solutions.
And they also looked at the computational cost of mind evolution compared to those other strategies.
So how did it do in terms of efficiency?
While mind evolution needs more computational resources than those simpler methods like OnePass, it's way more efficient than that sequential revision plus approach.
Okay, so it's a trade-off between performance and efficiency.
Now let's talk about that StegPoet task, which is a whole different ballgame.
The StegPoet task sounds pretty complex.
So it involves taking a hidden message represented as a sequence of numbers and encoding it within a piece of creative text.
And the LLM has to create this like word-to-number substitution cipher and then like weave those code words into the text, right?
Right. And they also added some constraints to make sure that the LLM couldn't just, like string together a list of code
So
words.
the text actually has to be like creative and interesting.
Exactly. They could also adjust how hard the steg poet task was by changing things like how long the hidden message was and how far apart the code words had to be.
So how did Mind Evolution handle this Steg Poet task?
Well, using the Gemini 1.5 Pro model, it got an 87.1% success rate on the validation set and a 79.2% success rate on the test set.
Wow, those are really good results, especially for such a unique task.
And those other baseline strategies, they really struggled with Steg Poet, which shows that just creating a bunch of solutions and picking the best one doesn't work so well for these kinds of tasks that need like a deeper understanding and creativity.
So Mind Evolution, with its exploration, refinement, and feedback, was much better suited for this challenge.
This research really gives us a lot to think about when it comes to pushing the limits of what LLMs can do.
It definitely seems like Mind Evolution has the potential to change the game when it comes to solving complex problems, and not just the traditional planning ones either.
It's exciting to see where this research goes next. There's still so much to explore and learn.
That's for sure. Well, this has been a fascinating deep dive into the world of evolving deeper LLM thinking.
We hope you found it as interesting as we did.
And we encourage you to keep learning and exploring this exciting field and all the amazing possibilities it holds for the future.